Good morning all. This is my first YouTube video and I thought of thinking of a catchphrase to start all my videos with, but that's a bit 80s. Anyway, what we want to do here today is look at a battery protection circuit. So, in South Africa, if you don't know, we're having a bit of a problem with, well, basically power supply. Our generating capacity doesn't match demand, and so from time to time the power utility will shut us down. This causes a problem, especially if you've got a Vumatel fiber connection. What happens is when power comes back, everybody's router tries to authenticate at the same time, and well, basically you can wait about 2 hours for your internet to come back. Quick and easy solution to this is to buy an old cheapo UPS. You can have them for about 600 Rand on Take-A-Lot. Not very great, modified sign, in other words a step square wave or something stupid like that. But it will hold the router up for some time. And if you're in one of those 2-hour power cut areas, that's probably not too bad and it'll probably last you through the power cut. Unfortunately, in Joburg, power cuts are generally 4.5 hours. So, the router doesn't hold, the UPS doesn't hold the router up long enough for us to outlast the power cut. The one way to get around this is to buy a bigger UPS. The other way to get around this is to mess around with some electronics. Now, you can have on Banggood, and I'll show you one in a minute, a couple of little voltage stabilizer step up, step down DC buck converter boards, which are going to be much more efficient than any UPS, which is stepping up to the full 220 volts. The problem with these, of course, is that quite simply put, you're going to have to either cut wires on your router power supply, or you're going to have to buy new plugs for it, or your CPE power supply, as the case may be. This may void your warranty. Not only that, just as a general disclaimer at the beginning, 12-volt battery has a fair amount of energy. You can heat things up quite a lot if you short circuit it. It's a fire hazard. It's in fact an explosion hazard, the little 12-volt batteries and the UPS. In a later video I'll probably review the UPS while I tear it to bits and replace its innards. But the idea behind this project is to build basically a replacement for the innards of the UPS that only drives the router and the CPE of DC buck boost converter board. So the problem with that is you need battery protection. So you need some sort of a battery protection circuit, because if you run your 12-volt battery flat, and the UPS may even do that, eventually it's going to stop working. You have to buy a new battery. It's a pain in the neck and it's a waste of time. So starting in this video, I'm going to prototype a battery protection board. The board is based on a design by, and let's get the window up, a design by, what is the guy's name? Let's just find him. Posted by Tim Nisk, and it's copyright Silicon Chip Electronics. Go and check out the link. I'll post it below. I'm not going to use exactly his design for a number of reasons. Main one being that the op amp, the LM358, actually has 2 op amps on board, and he's got a manual reset in order to restore power once the battery's charged up again. So in probably the second video in the series, I will automate that process somewhat. And we'll look at various ways we can do that, relating to whether the battery's charging or the voltage has recovered sufficiently. You don't want it to get into a feedback loop where when you disconnect the load, the voltage rises enough on a lead acid battery and it reconnects and then disconnects. That would not be very good for the router or probably the metal system. Bear in mind, everything done here should be done by someone who knows what they're doing. There is a fire hazard, there is an explosion risk, you could burn down your house, any number of things can go wrong. So I don't advise the uninitiated in electronics take on such a project. And if you do, please assume that this is your own risk. So one of the problems we have in South Africa is components are actually quite expensive. And I'll probably do an analysis of the cost of this project, but most of what you see, except for the meter, on the table before you comes from ordering on Banggood. You've got to have a bit of patience to do this sort of thing. And it actually works out quite reasonably. And maybe I'll post this on, maybe they'll give me some Banggood points. Anyway, what I'm going to do now is I'm going to cut away and I'm going to bring in the board and show you guys what that looks like. And then we'll get started building the circuit, possibly pretty much as is on the drawing as a starting point. I've got my bench power supply, also from Banggood. I maybe should link some things down, but yeah, whatever. If you're suitably motivated, you'll be able to find all the equipment and everything you need. And then we'll test the circuit. We'll run the voltage up and down, see that it cuts off in the correct place, and whether or not it does. Ultimately, I have a couple of prototype boards, and I will build the circuit, and I will eventually build the circuit into the inverter along with some sort of battery charging circuit, and a couple of these DC-DC boards, which are ridiculously cheap and actually quite a nice idea. I think we may try and review them and reverse engineer them as well. Okay. So this here is the heart of what I intend to do. As you can see, it's quite a small board. It's got inputs and outputs. I think the rating's about not zero, I think it's about 3.5 to 30 volts in. And you get between, I can't remember the lower limit, but upper limit, something like 30 volts out. And I sort of played around with one of these, and on the bench power supply you find that you can vary the voltage up and down past the sort of crossover point where your output is set, and it doesn't seem to vary much. Next thing, of course, is to try that with a load and an oscilloscope to see if we get any nasty spikes when we cross that threshold. In the case of my router, it's a 9-volt router, and if the battery's gone down to 9 volts, that's going to be bigger problems. So actually a step-down version of this board would work. I believe the CPE is a 12-volt system, and in that case it's quite possible to pass that threshold. And if you blow up your CPE, that's probably going to be quite expensive. Anyway, let's get started and let's build the circuit. Heart of the circuit is an LM358. I've already pulled one out of my electronics order, and I've placed it on my board. I've got my bench power supply coming in. I've actually got another board that I might use to power other projects, but because we want to vary the voltage, the bench power supply is ideal. On my breadboard, I've just bridged the power lines across so that we've got the bench power supply plus and minus on both sides. It's quite a large breadboard. The circuit will be quite small, and we'll sit around there. It might get a bit messy. I don't have the ideal, jumper cables and stuff. In the old days, used to use what they called telephone wire, single-strand copper cable, But that actually seems quite hard to come by these days. So now we've got these geek cred or whatever they are, little jumper cables that are sort of pre-terminated. You can stick them into sockets, you can stick them into breadboard. It works reasonably well. I've got a bunch of variable resistors for the set point. I've got a pack of Zener diodes. We might play around with. I think he said it's 4.7. Might see if there's not a better one depending on our variable resistor combo. I won't get into how op amps work. I've got a little N-channel MOSFET here. This will be the load cut in, cut out. Should be quite okay without any, heat dissipation. To run a couple of these boards in the router, we'll probably try and do some temperature measurements and find out if that's really true. But I doubt there'll be any problem for such a small load. By my calculations, a 7 amp hour battery should give me in the region of 4.5 or 5 hours running both devices. But I haven't done power measurements on the CPE current draw at this point. Okay, let's get started.